So up until now, we've been dealing with systems of equations, and they've been called systems of nonlinear equations, right? Now, somebody asked me the other day, why is this called a system of nonlinear equations when one of the equations in the system is a linear equation? Do you guys know the answer to that? Why is it called a system of nonlinear equations if there can still be a linear equation in the system? No, the answer is just a point, right? Just a point of intersection. There's more equations, right? All of them would have to be linear for it to be a system of linear equations. If they're all not linear, then it's a nonlinear system. In a nonlinear system, you're allowed to have a linear equation. You just can't have a nonlinear equation if it's a system of linear equations. Does that confuse you enough? We good? Okay. So, today we're going to kind of start to apply that. Now, we applied it a little bit last time with some of the things that we were doing, but geometry is something you guys have worked on like an entire year, even in your schooling, right? So this is stuff that you guys are very aware of and things that you know already, but I want to kind of talk through some of these with you. But first of all, I want you to circle number 4 and number 5 and number 10 and number 12. Okay? 4, 5, 10, and 12. Those are the only ones that we're doing for homework tonight. Yeah, the rest are extra credit, except for number 6. And I'm going to do number 6 for you. Okay? I'm doing number 6 because it's very similar to number 5. And it'll help get you on the right track even for number 4. And for 10 and 12 for that matter. Okay? So let's look at problem number 6. A right triangle has a hypotenuse that measures 26 centimeters. If one leg, y, is 14 centimeters longer than the other leg, x, how long are these sides of the triangle? Now, you're lucky because it tells you exactly how many equations you need. You don't have to guess. But then again, if we have 2 variables, how many equations do we need? 2, right? 2 equations to solve 2 variable systems. Okay, I've got an x and a y, so I need 2 equations. Anybody have any idea where one of the equations is going to come from? From the triangle, right? What do we know about triangles? Yeah, that's exactly right. What's that called? Pythagorean Theorem, right? We know from the Pythagorean Theorem that in this case, not just using A, B, and C's, but let's focus on this triangle exactly. Tell me what equation we're going to have to use. X squared plus y squared equals 26 squared. You want me to just write 26 squared for now and we can figure it out in a minute? Okay, I'll write it over here. I want it written 26 squared so when you go back to look at this to study, you'll remember where we started out. What is 26 squared? What you got? You don't got it? I don't think that's right. 676. Okay, that's what that is. So I'm just going to put it to the side so we can adjust that later when we go on. Okay? Well, we've got one equation. What do I need? Another one. Where do you think that's going to come from? Something about the 14, right? The sentence with the 14 in it. Y is 14 centimeters longer than x, right? If y is 14 centimeters longer than x, how do I write that equation? X plus 14 equals y. Does that say y is 14 centimeters longer than the other? If I added 14 centimeters to x, wouldn't those two values be equal? Yes, and that's appropriate. Very good. What you got? Okay. So now what? We solve it, right? I have to solve it. Now, work. You got to work. Okay? Work, 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 work. I think that's the dumbest song ever, but that's just my opinion. We don't even have to talk about that anymore. I just hope it didn't take her a long time to memorize the words. Okay. All right. How am I going to solve this? I could set it equal if they were both equal to y, but they're not. I probably want to use substitution. Now, hopefully you remember from last time when we actually worked on substitution. This is set up really nice. Y equals something. I could put that into the other equation where y is. But you could also look right here. It suggests substitution. This is just a suggestion. So, yeah, that's what those are for. Okay? That's why I was getting there. I didn't want to tell you what I'm beforehand. I want you to think. Okay? Here's the thing, though. Substitution is a suggestion. If you're more comfortable solving this a different way, okay. I recommend substitution, and when I would do this problem, I will do substitution because it's probably the best way. Okay? Then it suggests after that to use what? QF. What do you think that stands for? Quadratic formula, okay? Again, just a suggestion. So we'll think about that when we get there. So how do I start? Yeah, plug what I know for y in for y. Okay, so I'm going to start writing the first equation. X squared plus, well, I know y to be x plus 14 squared equals, now I'm going to go ahead and write 676. Are you okay with that? What do you want to do now? Thank you. What do you want to do now? We got to simplify, don't we? Now, if you write, first of all, do you know what 14 squared is? 186. If you write x squared plus 196 under here, I promise I will want to hurt you. No, I won't because I don't want to lose my job today. Okay, but I will want to. Because we've been doing this since I think 7th grade. Either 7th, maybe 8th grade. But some of you are juniors, some of you are seniors, and you have got to remember that x plus 14 squared is the same as x plus 14 times x plus 14. You cannot just square each term and go on. You cannot. Okay? We are past that. You've got to remember that. Okay? So, x squared, because of right there, plus, simplify this. What is x times x? What is x times 14? And then what is 14 times x? So if I've got two 14x's, can I go ahead and write 28x? You okay with that? And then I've got 14 and 14. Right? So I did that one, then that one, then that one, and then the last one. Distributive property, right? Equals 676. Now what? Okay, only two terms I can combine are those two right there, right? But I know it's a quadratic, so what else do I want to do? How about subtract this one? Why do I want to subtract that one? Very good. You all right? Oh, they can all be divided by 2, and if I want to make my life easier, I will divide them all by 2. Both sides of everything by 2, right? So that gives me, very good. Their suggestion is quadratic formula. Can I get the right answer if I do quadratic formula? Yes, but some people last period said, but why can't we factor it? You can. Their suggestion was quadratic formula. Remember I told you what are these? Suggestions. They're optional, right? They're suggestions. If you can look at this and see, wait a second, 240 is 24 and 10. I can get 14 from 24 and 10, can't I? Then factor it, okay? If you can't see that as easily to factor it, will quadratic formula work? Yes. Okay? So, do you want to factor or you want to use quadratic formula? Factor? Okay, what are my two factors then? So, x plus 24, x minus 10. Very good. So, what are my x's? Whoops, negative. And then x minus 10 equals 0, so x equals 10. So now talk to me. Tell me what we just found. We just found our x values for our equation, right? Go ahead. So we need to figure out our y values first of all? What do you mean we need to find out which one's the correct one? What do you mean by that? Like one of them might not work? Okay. So if I put negative 24 in right here, what's negative 24 plus 14? Negative 10. Okay. What if I put a 10 in right here? 10 plus 14? 24. Okay. So now I have to go actually answer the question, and he's bringing up a really good point. Say that again. In this problem situation, can one of these legs equal a negative length? No. So this, that gets a frowny face. Okay? When I go to write my solutions in my solution box, what does x equal? What does x equal? 10. Okay. And what does y equal? Okay, if this is what you wrote in your solution box on your test, you would get points off. Because you didn't answer the question. Read the question. So x is 10 centimeters. That's exactly right. And y is 24 centimeters. I don't care if you think that's picky. 10 doesn't answer the question. 10 what? Is it 10 dogs? Is it 10 children? 10 chicken nuggets? Although that sounds delicious, it's not the right answer. It's not the right answer till it's 10 centimeters. You okay with that? Okay, so you're going to set up equations. You're going to set up a system of equations. You're going to solve it by showing your work. Then you're going to answer the question that's being asked up here in the problem in the solution box. Now, part of my y is not in the box. It is okay. Yeah. Okay. If you write big like I do, you can get your answer some out of the box as long as it's in that area so I can find it easily, so you can find it easily. Okay? Because all this does right over here is answer the equation. This answers the question. Do you see the difference? Because I got two answers to my equation, didn't I? But this one can't work in the solution of the question because we can't, in this problem, have negative distance. Okay? Any questions? Come up with a system, show your work to solve it, and answer the question.